The take-up formula for 3-inch and 4-inch GRC, which stands for Galvanized Rigid Conduit, involves calculating the length of cable or wire required for the take-up. This calculation depends on two primary factors: the length of the GRC and the diameter of the GRC. The length of GRC, represented as L, is measured in feet. The diameter of the GRC, represented as D, is measured in inches, and in this case, it will be either 3 inches or 4 inches. Formula is expressed as take-up equals L divided by D multiplied by pi, the result of which is multiplied by 16. In this formula, take-up represents the length of cable or wire needed, expressed in feet. L represents the length of the GRC in feet. D represents the diameter of the GRC in inches, which will be either 3 inches or 4 inches. Pi is a mathematical constant that is approximately equal to 3.14159. Now, let's apply this formula to an example. Suppose you need to calculate the take-up for a 50-foot length of 4-inch GRC. First, you substitute the values into the formula. So the equation becomes take-up equals 50 divided by 4 multiplied by pi, and that whole result is then multiplied by 16. Now we solve, starting with 4 multiplied by pi. 4 multiplied by pi is approximately 12.566. Then we divide 50 by 12.566, which is approximately 3.979. Next, we multiply that result by 16. 3.979 multiplied by 16 is approximately 63.72. Therefore, the approximate take-up is 63.72 feet. Remember, this formula provides an approximate value. It's always best to allow for additional take-up to ensure safety and accommodate handling. In practical applications, it's also a good idea to round up to the nearest whole number. In our example, you would round 63.72 feet to 64 feet to ensure you have enough cable or wire for the take-up. When working with electrical conduits and wiring, accuracy is crucial. Take-up refers to the additional length of wire or cable needed to make bends, connections, or other necessary manipulations within the conduit system. Underestimating the take-up can lead to insufficient wire length, resulting in rework, delays, and potential safety hazards. Overestimating, while less problematic, can lead to unnecessary waste of materials. Understanding the factors that influence take-up and applying appropriate calculation methods are essential for efficient and safe electrical installations. The primary factors influencing take-up in conduit systems are firstly, the diameter of the conduit. Larger diameter conduits generally require more take-up due to the greater circumference of bends and the increased space needed for connections. Secondly, the angle and radius of bends. Sharper bends with smaller radii necessitate more take-up compared to gradual bends with larger radii. Thirdly, the number of bends. Each bend in the conduit system adds to the overall take-up requirement. More complex systems with multiple bends will naturally require more additional length. Fourthly, the type of connectors and fittings. Different types of connectors and fittings, such as couplings, elbows, and pull boxes, contribute varying amounts to the take-up. The specific dimensions and designs of these components must be considered. Fifthly, the method of installation. The techniques used to install the conduit, such as the use of prefabricated bends or field bending, can influence the amount of take-up needed. Precise and consistent installation practices help minimize variations in take-up. Several methods can be employed to calculate take-up in conduit systems, each offering different levels of accuracy and complexity. Firstly, the empirical method, also known as the rule of thumb method, involves using predetermined values or rules based on experience and industry standards. These values are typically expressed in terms of additional length per bend or fitting. While simple and quick to apply, this method may not be accurate for complex systems or non-standard installations. Secondly, the geometrical method involves calculating take-up based on the geometry of the conduit bends and fittings. This method requires accurate measurements of bend angles, radii, and fitting dimensions. Trigonometric formulas or CAD software can be used to determine the additional length needed for each bend or fitting. This method offers higher accuracy compared to the empirical method but requires more detailed information and calculations. Thirdly, the simulation method involves creating a virtual model of the conduit system using CAD software or specialized simulation tools. The software can then simulate the bending and installation process, providing accurate take-up values based on the specific parameters of the system. This method is particularly useful for complex systems with multiple bends and fittings, as it can account for interactions and cumulative effect. To ensure accurate take-up calculations, it is crucial to follow a systematic approach and pay attention to detail. Firstly, gather accurate information. Collect precise measurements of conduit diameters, bend angles, radii, and fitting dimensions. Consult manufacturer specifications for detailed information on fitting take-up values. Secondly, choose the appropriate method. Select the calculation method that best suits the complexity of the system and the available information. The geometrical or simulation method may be preferable for complex systems, while the empirical method may be adequate for simpler installations. Thirdly, perform calculations carefully. Double-check all calculations and ensure that units of measurement are consistent. Use calculators or software tools to minimize errors and streamline the process. Fourthly, account for additional factors. Consider factors such as wire sag, connect to pull-in, and potential obstructions that may affect the take-up. Add extra length to account for these factors and provide a margin of safety. Fifthly, verify and validate. After completing the calculations, verify the results by comparing them with actual measurements or simulations. Validate the take-up by installing a section of the conduit system and measuring the required wire length. Several strategies can be employed to minimize take-up in conduit systems and optimize material usage. Firstly, use gradual bends. Opt for bends with larger radii whenever possible. Gradual bends require less take-up compared to sharp bends and also reduce the risk of wire damage. Secondly, minimize the number of bends. Simplify the conduit layout to minimize the number of bends required. Straight runs and direct paths reduce the overall take-up. Thirdly, use prefabricated bends. Consider using prefabricated bends with standardized radii. Prefabricated bends ensure consistency and accuracy, minimizing variations in take-up. Fourthly, optimize fitting selection. Choose fittings with minimal take-up values. Consult manufacturer specifications and compare different fitting options to identify those that require less additional length. Fifthly, plan the installation carefully. Plan the installation sequence to minimize unnecessary bends and fittings. Coordinate with other trades to avoid obstructions and ensure a smooth installation process. Several software tools and resources are available to assist with take-up calculations and conduit system design. Firstly, CAD software such as AutoCAD or Revit can be used to create accurate models of conduit systems and perform geometrical calculations. These tools allow for precise measurements and simulations, facilitating accurate take-up determination. Secondly, specialized conduit bending software such as Greeny's BendWorks or Ideal's Conduit Bending Calculator provides pre-programmed formulas and tables for calculating take-up based on conduit size, bend angle, and radius. These tools streamline the calculation process and minimize errors. Thirdly, online resources and calculators. Numerous websites and online tools offer calculators for estimating take-up in conduit systems. These resources typically provide simple interfaces for inputting conduit parameters and obtaining quick take-up estimates. Finally, manufacturer catalogs and specifications. Manufacturers of conduits and fittings provide detailed catalogs and specifications that include take-up values for their product. These resources are essential for obtaining accurate information and ensuring proper installation practices. Best practices for managing and documenting take-up in electrical projects include: firstly, maintaining detailed records. Keep accurate records of all take-up calculations, measurements, and simulations. Document the specific parameters of the conduit system, including conduit sizes, bend angles, radii, and fitting types. Secondly, creating as-built drawings. Update the project drawings to reflect the actual installed conduit system, including the locations and dimensions of all bends and fittings. As-built drawings serve as a valuable reference for future maintenance and modifications. Thirdly, using color coding or labeling. Employ color coding or labeling systems to identify conduits and fittings with different take-up requirements. This helps prevent errors during installation and ensures that the correct wire lengths are used. Fourthly, training and communication. Provide adequate training to electrical workers on proper take-up calculation methods and installation practices. Foster clear communication among project stakeholders to ensure that everyone understands the take-up requirements and their impact on the project. Finally, regular inspections and audits. Conduct regular inspections and audits to verify that take-up calculations are accurate and that installation practices are in compliance with industry standards and project specifications. Remember that the information provided is for general guidance only. Always consult with qualified electrical professionals and adhere to local electrical codes and regulations for specific applications. In addition to the general formula and best practices, it's helpful to understand some common scenarios and rules of thumb that can aid in quick estimations and decision-making. For example, for a 90-degree bend in a 3-inch GRC, a common rule of thumb is to add approximately 18 inches of take-up. For a 90-degree bend in a 4-inch GRC, a common rule of thumb is to add approximately 24 inches of take-up. These values can vary depending on the bending radius, so it's always best to consult specific bending charts or use the formulas discussed earlier for precise calculations. Another important consideration is the type of wire or cable being used. Different types of conductors have different bending radii requirements. Solid conductors typically require larger bending radii than stranded conductors of the same gauge. Exceeding the minimum bending radius can damage the insulation and compromise the integrity of the conductor. Always consult the manufacturer's specifications for the minimum bending radius of the specific wire or cable being used. When multiple conductors are being pulled through the same conduit, it's important to direct the ampacity of the conductors according to the National Electrical Code, or NEC. The NEC specifies directing factors based on the number of conductors in a raceway. Directing reduces the allowable current carrying capacity of the conductors to prevent overheating. Take this into account when selecting the appropriate conductor size and calculating the overall take-up requirements. Furthermore, when working with underground conduits, it's essential to consider the effects of soil conditions, moisture, and temperature. Underground conduits are often subject to corrosion and physical damage. Using appropriate corrosion-resistant materials and installation techniques is crucial for ensuring the long-term reliability of the system. Also, temperature variations can cause expansion and contraction of the conduit, which can affect the take-up of the wires or cables inside. Always allow for sufficient slack to accommodate these movements. Pull boxes and junction boxes are often used in long conduit runs to facilitate wire pulling and provide access for future maintenance. Placement and sizing of these boxes should be carefully considered to minimize the number of bends and the overall take-up. Pull boxes should be located at strategic points to break up long runs and reduce the pulling tension on the conductors. The size of the pull box should be sufficient to accommodate the number and size of the conductors being pulled, as well as any splices or terminations. Proper grounding and bonding are essential for electrical safety. All metallic conduits, boxes, and enclosures must be properly grounded and bonded to create a low impedance path for fault currents. Grounding and bonding conductors must be sized and installed according to the NEC. Ensure that all connections are tight and corrosion resistant. Finally, always remember to inspect the completed conduit system before energizing the circuit. Check for any signs of damage, such as dents, cracks, or loose connections. Verify that all supports and fasteners are properly installed. Perform continuity tests to ensure that all conductors are properly connected and that there are no shorts or grounds. Once you are satisfied that the system is safe and compliant, you can proceed with energizing the circuit. However, always exercise caution and follow proper lockout/tagout procedures to prevent accidental energization. By following these best practices and paying attention to detail, you can ensure that your conduit system is safe, reliable, and compliant with all applicable codes and regulations. Always prioritize safety and consult with qualified electrical professionals when in doubt. Understanding conduit fill requirements is crucial for ensuring the safe and efficient operation of electrical systems. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. Exceeding the maximum allowable conduit fill can lead to overheating, insulation damage, and difficulty in pulling wires. The NEC specifies maximum conduit fill percentages based on the number and type of conductors in the conduit. For example, for conduits containing 3 or more conductors, the maximum allowable fill is typically 40%. For conduits containing only 1 conductor, the maximum allowable fill is typically 53%. These percentages are based on the cross-sectional area of the conductors, including insulation. To calculate conduit fill, you need to determine the cross-sectional area of each conductor and then add them together. The cross-sectional area of a conductor can be calculated using the formula area equals pi multiplied by the radius squared. The radius is half of the diameter of the conductor. Once you have calculated the total cross-sectional area of the conductors, you can divide it by the cross-sectional area of the conduit to determine the conduit fill percentage. It's important to use the correct conduit size to ensure that the conduit fill does not exceed the maximum allowable percentage. If the conduit fill is too high, you will need to increase the conduit size or reduce the number of conductors. Another important consideration is the type of insulation used on the conductors. Some types of insulation are thicker than others, which can affect the conduit fill. Always use the dimensions specified by the manufacturer when calculating conduit fill. In addition to conduit fill, it's also important to consider the ampacity of the conductors. Ampacity refers to the maximum current carrying capacity of a conductor. The NEC specifies ampacity ratings for different types of conductors based on their size, insulation type, and installation conditions. The ampacity of a conductor must be sufficient to carry the load that it will be supplying. If the ampacity is too low, the conductor can overheat and cause a fire. It's also important to consider the voltage drop in the conductors. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, you can increase the size of the conductors or reduce the length of the circuit. When installing conduits, it's important to use proper bending techniques to avoid damaging the conduit or the conductors inside. Conduit should be bent using a conduit bender that is designed for the specific type and size of conduit being used. The bending radius should be large enough to prevent kinking or flattening of the conduit. When pulling wires through conduits, it's important to use a wire lubricant to reduce friction. The lubricant should be compatible with the type of insulation used in the conductors. The wire should be pulled smoothly and evenly to avoid damaging the insulation. After the wires have been pulled, the conduit should be properly supported to prevent sagging or movement. The support should be spaced according to the NEC. Finally, all conduit connections should be tight and secure to prevent moisture from entering the conduit system. Moisture can cause corrosion and damage to the conductors. By following these guidelines, you can ensure that your conduit system is safe, efficient, and compliant with all applicable codes and regulations. Remember to always consult with qualified electrical professionals and adhere to local electrical codes and regulations for specific applications.